So now the potentiometer, I use a Trimpot, as I think most people do. These days it's a smaller potentiometer. A trimmer potentiometer is a resistive element. There's 3 terminals, but 2 of them you can put across a supply voltage. You can also, skip using one if you just want to use it as a variable resistor. But in any case, you put the voltage across it and you can get all the way down to 0 volts or all the way up to the full positive supply voltage, anywhere in between, as an output voltage. But that is not meant to provide power. If you have the Trimpot, I'm going to say, instead of potentiometer, and a load connected to the output, usually if you have an LED, you have a relatively low value resistor. You just want to limit as much current as needed to light the LED to the brightness you want. If you also try to set the voltage across it by using a potentiometer or Trimpot right there, you run into a problem because the current that goes through the load also has to go through the resistance of the Trimpot, and therefore you're actually going to get a lower voltage out. Current's going to be limited more than you want because you got more resistance than you want. And the way to overcome that instead is we're going to use an NPN bipolar junction transistor. You can do the same with the PNP, but polarities would be opposite. And so just be aware of that. But in any case, we got the voltage. We can set the voltage to the base. When you wire up the NPN bipolar junction transistor as an emitter follower, you can see the load here is to the emitter side right there. Then what happens is whatever voltage you set to the base, remember it's a diode, so you lose about 0.6 volts, but whatever voltage you got here, about 0.6 volts less will be at the emitter, and that's in relationship to ground. So you can set, we got 12 volts, you go halfway. Let's go a little bit above halfway, just to make it simple. We set 6.6 volts there, we'll have about 6 volts here, and then going through the LED. Using a red LED, 1000 ohm resistor, this will drop about 2 volts. We'll have about 4 volts across the resistor, 6 volts total, and about 4 milliamps of current, and so on. This 10K resistor, probably most circuits you don't need it, but when you have, like LEDs, they drop some voltage and stuff, it may kind of make the base not realize where 0 volts ground is. But with this resistor there, it does a better job. So you'll have a more solid voltage in relationship to the base at the emitter with this resistor there, so it has a sense of where ground is. And you can take multimeter measurements of this as well. That's what that means. Those are multimeter voltage measurements to look at that. But in any case, so just in case I wasn't going to cover this, but I just noticed it. In case you didn't know, this is the symbol for the NPN bipolar junction transistor. The arrow there is where the emitter is. The base is over here on its own side of the bar, and then the line with no symbol or anything added to it is the collector. You got to put it in the right way. I'm using the 2N3904. When you look at the flat side, we've got emitter, base, collector. The emitter is at the bottom. That's where the long lead, the LED, remember, you got to put it in the right way. And the 10K resistor are down there. Base in the middle, coming to the Trimpot output, and then we got the collector on top. Now, you have to be careful when you have no resistance at the output. We can connect all the way to the positive supply and all the way to the negative supply. So the base current wants to flow this way, right there. It's much harder to flow that way. So if we go all the way to ground, we're okay. We don't have enough voltage, 12 volts, to make a path right there. We're perfectly fine. If you accidentally put this in backwards, you would get leakage. The emitter's not as strong. But the collector will not pass current positive and negative that way. So we can go all the way to ground. And then we can go all the way to the positive supply because the base to emitter here has resistance along the way. So if this was a circuit where the emitter is directly to ground, then you would need some resistance, or you could add resistance above the Trimpot to make sure there's always current limited going that way. But here we have the load in this 10K resistor limiting the current, so we don't have to worry about that. But yeah, in any case, I explained that good enough. If you're using if it doesn't start with 2N and it's a bipolar junction transistor, good chance it has a different pin layout. Be aware of that. Always check the data sheet for the particular component you are using. But in case, here we got it. We got 0 volts, and now we go about halfway, and that's a 1000 ohm resistor right there, limiting the current. And we have about, this is a 10K Trimpot, about 5,000 ohms of resistance that the signal is going through. So this would be far less bright if we were just trying to power it directly with the Trimpot. In fact, we can actually do that. We will plug this, plug that, move the LED up, and breadboard, it's extremely quick to make changes. And there you can see how dim the LED is compared to when it has the transistor. And I put the circuit back together, just edit it out, and there you can see it's brighter. And we can, of course, increase this. As I said before, we can go all the way to the supply rail there and the supply rail there with a direct connection. I already explained why. The direct connection to positive there will not go to negative there at this low voltage. We are using 12 volts. I can show you the power supply. And we can also get an estimate of how much current is flowing. There's less than a milliamp, or yeah, think about 1 milliamp of current flowing from positive to negative there, approximately. And because it's a 10K Trimpot, and we're just slightly above 10 volts. So you could expect 1 milliamp of current. But yeah, there we go. We go all the way up. We got about 12 volts. Red LED is dropping about 2 volts though. 1K resistor, we can expect about 10 milliamps of current approximately right there. And you can see the current changing. So the resistance of the Trimpot is not factoring in at all, basically, when it comes to how much current is flowing through the LED, because the resistor sets it based on the voltage that the transistor puts across the load, which is the base voltage, the Trimpot voltage, minus about 0.6 volts. And we will actually measure that. We got the multimeter, just got to set it to V. For this particular one, it's auto ranging, and I don't have to move the red probe for anything but high current, and we'll zoom in a little bit, make it a little easier to see. Bring the black probe to anywhere. We got the negative supply, that's our 0 volt ground reference point. Now we're going to measure the voltage at the Trimpot, and I was shooting for about 6.6. I liked where the arrow already was, and that's kind of what I estimated what it was going to be. And that is pretty good. And once I get a good connection, there you can see at the emitter, which is also the long lead, the anode of the LED, we got 6 volts, 0.6 volts less than what we set at the Trimpot. If we were powering this directly, then it would be thrown off. Again, we'll do that real quick. Let's look at the voltage that will get across the load when we just go directly to the Trimpot. And there you can see it's pulling it down because this is headed to ground, so it's going to pull the voltage down. We don't want to draw any current out of the Trimpot to maintain our voltage. And so in any case, that's it. Make sure you turn the meter off when you are done. Thanks for watching. Make sure you check out one of the other videos I posted on the screen, and check out the links down below. They all help out a lot. I'll see you in the next video.